exam was pathology. That was the toughest exams in the whole final exams. So everyone participating in this study is very stressed out. So it's just out and summer vacation, very relaxed here and there. But 3 days later, final exams were waiting. So they was stressed out and their hostility was raised. It's very natural. But look at this group. Nothing happened here. So even if there was a stressful thing, they behave themselves as usual. So the conclusion of study 1 is DHA controls hostility at times of mental stress in young adults.
Alterations in DHA in the endocrine cortex of patients with schizophrenia, major depression, and bipolar disorder. No difference between the non-suicide and suicide group. The changes in the other fatty acids such as docosahexaenoic acid in major depressive disorder might be due to decreased level of messenger RNA, which is responsible for NOx5. Change in long-chain PUFAs in these psychiatric disorders may be split to certain brain regions, so further investigation is warranted. And we are right now working on.
As a result, attention of health control is better. It's as you imagine. And then processing speed. In TMA, train making task A and DG symbol, better performance and healthy, but not in finger tapping. I mean the processing speed in cognitive function is decreased in depression. In executive function, as you imagine, through Wisconsin card and verbal fluency is decreased in depressed people. In memory, surprisingly, in many previous papers, there is no memory declining during depression. But in this meta-analysis, there is a decrease in immediate recall in verbal memory, not in visual memory tests. So we can say that during depression, there is a cognitive decline in attention and processing speed and executive function and verbally and the memory, especially in verbal memory, immediate memory.
Why inflammation can change brain function? Why they can cause depression? So this is another very big topic. Whole European Union now they work on this answer this question through the several pathways. So we started from 1998. First of all, is find the ideal enzyme. So this ideal enzyme usually can activated by pro-inflammatory cytokines, and then they break down tryptophan and reduce the serotonin, so cause depression. And second pathway is they change the quinolinic acid. They can metabolize this acid, then increase the monoamine oxidate, so break down serotonin or noradrenaline, cause depression as well. And the third pathway from the quinolinic acid, it can cause neurodegeneration. So that's why in depressed patients there is a cognitive decline during this diseases. And the third is the AMD receptor has been involved glutamate, now increased glutamate, increased AMD receptor expression has been reported in depressed patients. So you can see this hippocampus, you can change hippocampus glucocorticoid receptor downregulate, so this can cause depression as well. And we know NMD receptor can induce the neurodegeneration. So this pathway has been worked for 20 years now, but more and more clear in the past many years.
So this result has brought us much more information than ever found that. And actually, Omega-3 is efficacious and present. Okay. In a few aspects. If you want to treat the depression with DSM or DSM-based MD major depression, effect is significant. If the depression is with higher severity, effect is significant. If the EPA is higher in the supplement, effect is good.
So we look at the association between the spatial working memory and DAT1 gene. And we do find that 3 SNAPs and haplotype BRCA1 were significantly associated with spatial working memory double errors. And 2 SNAP and the same haplotype BRCA1 was significantly associated with spatial working memory within errors. So finding that DAT1 may also mediate the neuropsychological deficit in ADHD. So we would like to hope that our further imaging genetic study can have more findings, and we also work on the non-genetic genes. So in summary, my talk is we find that executive functions, visual memory, attention lapse, and time perception deficit, frontal striatal, and related circuitry may be the potential endocrine type for ADHD. Second, our findings of association between the DAT1 gene and the inattentive symptoms, inattentive subtype, and spatial working memory support the role of dopaminergic deficit in ADHD.